Hello! In this video, we will discuss how to use the Timeline Analysis tool. The Timeline Analysis tool is a visualization tool that helps you track changes in specific dimensions across two or more observations. To use this analysis tool, you must first click Analysis, go to Timeline View, and select the classroom you would like to analyze. I will choose the example classroom. Now, you must select the graph type. The choices are contributions and equity ratio. By selecting contributions, the graph will show a distribution based on how often each student contributed to the discussion. Equity ratio will display these data in terms of equity ratios instead. I'll talk more about this later when I showcase that option. For now, I will select contributions. The next step is to choose the observations for which you would like analytics. You must choose at least 2 observations, but you can also choose more. Also, depending on the dates of your observations, you may need to drag the timeline graph to view earlier or later observations than the ones already displayed. Notice that only the whole class observations are highlighted. If you want to specifically look at the analytics for the small group observations, then you should go back to the analytics page and select the group work option. More information on that will be given in the group work analytics video. I will select all 3 observations. The resulting visual will show changes in student participation across the 3 observations. Now you must select a demographic. I will choose gender. A discourse dimension, for which I will choose student talk type, and an option. Option refers to the choices for a given discourse dimension. So since I chose student talk type, I must choose either to look at explanation, procedural, or factual/recall contributions. I will choose explanation. Contributions that are coded as explanations are typically high-level contributions, which makes them meaningful for learning. The resulting visual will be several line graphs, one for each gender, displaying the changes in the amount of contributions that were coded as explanation across the 3 observations. In the first observation, you see that girls did more explaining than every other gender. Then, in observation 2, the amount of explanations increased for boys and non-binary students, but decreased for girls. This time, the boys did more explaining. In the third observation, boys and girls provided more explanations than they did in observation 2, but non-binary students did not provide any explanations. Once again, the boys explained more than any other group in the third observation. This information is worth noting, given the fact that there are more girls in the class, 16, than boys, 12. Now let's go back and choose equity ratio. The equity ratio gives the actual participation for groups divided by their expected participation based on demographic representation. An equity ratio of 1 means overrepresentation, less than 1 means underrepresentation, and exactly 1 means that students participated as expected based on their representation in the class. While EQUIP can't specify the perfect distribution for an equitable classroom, a general guideline is that we want the equity ratio to be above 1 for groups of students who are minoritized in a discipline. So for women in mathematics, an equity ratio of 1/2 would be a signal to the instructor to adopt strategies to create a more supportive environment for women. So by selecting equity ratio, the visual will show line graphs depicting changes in equity ratios across observations. This will account for the sizes of the demographic group. For instance, in the contributions graph view, we saw that non-binary students participated once in the first observation, twice in the second, and no times in the third observation. The equity ratio view will contextualize those amounts with respect to their representation in the classroom. In the first observation, boys and non-binary students had equity ratios less than 1. Thus, they contributed less explanations than expected, whereas girls had an equity ratio greater than 1, indicating that they contributed more than expected. In the second observation, the equity ratios for boys and non-binary students increased, whereas the girls' equity ratio decreased. So, in observation 2, non-binary students participated more than expected. If you hover over that node in the graph, you will see more information about the data point. So, in this observation, non-binary students had an equity ratio of 1.64, since they contributed to 15.38% of the explanations, though they only made up 9.38% of the class population. We can repeat this process for each of the points. By the third observation, girls and non-binary students were underrepresented or contributed less explanations than expected, while boys were overrepresented. They contributed more explanations than expected. You can repeat these steps for all combinations of a selected demographic, discourse dimension, and dimension options.